Hi, my name is Anshu and welcome to my channel Bottleneck. This is a data structures and algorithm series. We are going to implement all the solutions using functional programming approach. Alright, now in our previous videos we discussed about what is dynamic programming and we also discussed about the different types of dynamic programming. Now we also started implementing Fibonacci series, which is very well known example used in dynamic programming to explain the different approaches. The first solution we implemented was recursive, which was a non-dynamic programming approach where we saw how data is going to traverse and how the each loop will work and what would be the time complexity. After that, we implemented a top-down approach where we optimized on the recursive solution using an intermediate data structure. In top-down approach for dynamic programming, we hold the intermediate results in a data structure and we use them to evaluate the next step or find the optimal solution. Alright. Now, if you have missed on my previous videos, I will share the link in the description as well as all the code will be available in the GitHub for your reference. Alright. Now, the final one for the Fibonacci is the bottom-up approach, which is basically optimization on top-down. Bottom-up approach. Alright. In bottom-up approach, we are going to optimize on the space utilization. Now, when it comes to top-down approach, there are use cases where you have to use top-down approach. That is, for example, Sudoku, where you need to s- uh, save all the intermediate calculation in memory so that you can evaluate the next value. Also, you need to validate. But when it comes to find the maximum height for a given sequence or a given condition, then in that case, you can use the bottom-up approach. All right, so let's see how it works. So it's going to be val fib bottom up approach. All right, so it is going to return a method for int to int. All right, it is going to take input value, that is the nth index, and it is going to return a method. So this is an anonymous method, so it is like before, n is equal to 0, return 0, else if as before n is equal to 1, it returns 1, else. Now watch closely, if it is going to 2 until n. Alright, now again we are going to use the for left. Now unlike we sub provided a data structure, here we are only interested in the initial or the last two values, as the formula goes n minus 1 and n minus 2 to calculate the next value. Alright, now we are going to evaluate the next value using a pattern match. So we have provided a comma b as the input and the third value is the index, which we are not interested. All right, now so if you notice that we have used the index earlier, but here we are not concerned about the index. It is going to return the Fibonacci number. All right, now we are interested in the last value, so it is going to be underscore 2. All right, now as we see, we have implemented the bottom-up approach. Let's see how efficient it is and whether we have achieved our target. Alright, so it is going to be start time 2, it is going to be result 2. Let's rename it as Fibonacci bottom up approach and time 2. Alright, it is going to be difference 2 and let's subtract the value and time, and alright, so now it is okay, perfect. Let's run it and see whether we are going to achieve as what we expected. All right, so let's run this. All right, so as we see that the bottom up approach and top down approach, so there is a difference. All right, so we can see there is a huge saving in terms of time. Okay, I think it has to be 2. Okay, now let's run it. All right, now we can see we have a significant difference in terms of time as well as in terms of space. So bottom up approach is the more optimal and it has a trade-off, but very minimal trade-off with respect to space, and it also saves on the time because everything or all the calculations are done in memory. However, for sequence you can also replace it with a dictionary or a map, and you can test it accordingly, so you might get a difference in the runtime, but eventually the bottom up approach will always have upper hand. Now you can use either of them given the use case supports that. So if you enjoyed this video, please like and subscribe, and in the following video we will be implementing more solutions on the dynamic programming, and we will see how the dynamic programming will improvise or help us with respect to the time and space complexity, and how we can optimize on the target. All right. So see you in the next video. Thank you.